Hi, I'm Sam Martinez, and this is my AP problem number 3. So, methane gas reacts with chlorine gas to form dichloromethane and hydrogen chloride as represented by the equation above. So for A, we have a 25-gram sample of methane gas is placed in a reaction vessel containing 2.58 moles of Cl2. We need to identify limiting reactant when the methane and chlorine gas are combined. So, we get 25 grams of CH4 and we divide it by its molar mass, which is 16.04, and we do the molar ratio. So for every mole of CH4 we have 2 moles of Cl2, so we get 3.12 moles of Cl2. So Cl2 is limiting reactant because there is enough CH4 to react with 3.12 moles of Cl2. However, there is only 2.58 moles of Cl2. So for Roman numeral 2, we have to calculate the total number of moles of CH2, Cl2 in the container after the limiting reactant has been totally consumed. So, the limiting reactant was Cl2, so we take the moles of Cl2, which is 2.58, and we do the molar ratio. So for every 2 moles of Cl2, there's 1 mole of CH2Cl2, so after we do that, we get 1.29 moles of CH2Cl2. So, for number 2, iron reacts with oxygen to produce iron 3 oxide as represented by the equation above. A 75-gram sample of iron is mixed with 11.5 liters of oxygen at 2.66 atm and 298 Kelvin. So first, we start off by balancing the equation above. So we just add a coefficient of 3 over 2 to the oxygen, and now the equation is balanced. For A, we have to calculate the number of moles of each of the following before the reaction begins. So first we have to find the moles of iron. So we take its mass, which is 75 grams, and we divide it by its molar mass, which is 55.85 grams, and we get 1.34 moles of iron. Then for oxygen, we have to use PV equals nRT, which is the ideal gas law, and we plug in 11.55, which is its volume, 2.66 atm, which is its pressure, and that's equal to N, which is the amount of moles, times 0.0821, which is R, the constant, times 298 Kelvin. So we get 30.59 is equal to 24.47 N, and we divide 30.59 by 24.47, so we get N is equal to 1.25 moles. So oxygen is equal to 1.25 moles. For 2B, we have to identify a limiting reactant when the mixture is heated to produce F2O3. So first we take the moles of iron, which is 1.34, and we do the mole to mole ratio. So for every 2 moles of iron, there's 1 mole of Fe2O3. So we get 0.670 moles of Fe2O3. Then we take the moles of oxygen, which is 1.25, and we do the molar ratio. So for every 1.5 moles of oxygen, there's 1 mole of Fe2O3. So we get 0.833 moles of Fe2O3. So the limiting reactant is Fe, which is iron. For C, we have to calculate the number of moles of Fe2O3 produced when the reaction proceeds to completion. So it's pretty much the same thing as our calculation above for iron. So we just take the moles of iron, which is 1.34, and we do the molar ratio. So for every 2 moles of iron, there's 1 mole of Fe2O3, and we get 0.670 moles of Fe2O3, which means that when the reaction is complete, there's 0.670 moles of Fe2O3.